So hey guys, we are back with another research paper video. So in this video, we are going to talk about the latest paper from Google, and that is Astute RAG. So the headline itself says overcoming imperfect retrieval augmentation and knowledge conflicts for large language models. So they have made it pretty clear what they are trying to tackle and sort of hints that how they are going to do it. So this paper actually helps a lot of people if they are trying to tackle the problem of retrieval plus the knowledge conflicts that are there within the internal knowledge of a model, or let's say external knowledge that you're getting from the retrieval database, right? And this paper is really good, but I have some issues with the cost cutting and everything that a company tries to do when they are trying to go through these type of techniques. So that we are going to talk about the very end. So I think we can start. So what they are saying, that the current systems are having a lot of conflict when it comes to external knowledge that we are getting from retrieval database, or the internal knowledge of a LLM, when to use that and when to not use, right? When we are performing the RAG, that is retrieval augmentation generation, right? So but this can be done using that technique of Astute RAG. They are also saying that we are proposing this technique that is going to not only help in resolving this conflict, but can also help in cases where let's say the retriever has become a very big problem. We know that the current parsers, or let's say retriever part of the models from the databases, is not that good, because code size similarity is the current most famous technique for used for retriever. But I personally feel we are not still at the peak. So let's go. And what they are saying, the problem statement, that the current systems that they have tested on, they took internal testing in their team, and what they came up with, that 45% were correct. In that case, both LLM and RAG were correct, and there is no improvement space here, right? And similarly, 35% which were incorrect, where the RAG and LLM both were incorrect. So there, here also they say it is very hard to improve here because both things are failing at once. But this 19%, or you can say around 19.2%, this we can try and try to improve and increase the accuracy, because let's say 45% is the total accuracy. Even if you can take out of 19 we can take 9 to 10%, that will be a huge boost, taking it to 55 to 54%. So yeah, so how are we going to do that? The place where LLM is incorrect and the RAG is correct, we need to leverage RAG to address LLM's knowledge gap, right? And the place where the RAG is incorrect but the LLM was correct, there we need to mitigate the RAG errors with LLM's internal knowledge, right? So we are going to take help from each one of them for the other case. So we are going to do that only. We are not going to use any third party thing. We are just going to use the current system only, taking help of each other, right? So yeah. Uh, Now let's go. What are they saying? That the correct they took these four data sets, the NQ, TripQA, BioASQ, and PopQA, right? And here the frequency percentage with the retrieval precision. So you can see, guys, 0% is also there 34% of time. Just imagine there was 0% retrieval precision. And similarly, you can see 25 and 34, 50% here at PopQA. So you see, retriever is still a very big problem for us right now. And how are they calculating this? The number of retrieved passages containing correct answer divided by the number of total retrieved passages multiplied by 100, obviously. So yeah, pretty straightforward. Now, what are they saying? That what they are planning to do. Let's see. Let's go one by one. I'll directly come to this code. But before that, we need to understand how currently RAG systems work. You have this document, this embedding model, the vector store, the query by the user, the LLM, and the output, right? So let's go one by one. Let's say you put a query, okay, and you, first of all, if you have a conversation history, that it is going to get rephrased. Now on the basis of this, you are going to have a vector base, right? Vector base. Now in this vector base, where you have the query, all the documents embedded already, this query will also get embedded, and you will perform a, let's say, cosine similarity search, right? Out of this vector database, you are going to guess something output from it. Let's say top 10, top 5, top 6, top 7, something like that, right? Now you are going to pass that query along with the retrieved content to the LLM, and you will be expecting an output from it, right? Now here comes the twist. What they are saying, say we will have a query, we will have passage, large language models, and the number of iterations tree. This you can forget for now. I'll explain it to you later. Okay. Now they are saying the max number of generated passages m prompt templates. They have 3 prompt templates, and for God's sake they have mentioned it in the appendix section, so you guys can go and definitely use it. What they are saying, when we are giving a query, let's use LLM to generate some passages around it. This we will definitely keep, but we will use LLM to generate some more passages around that query. Let's say the query is, I need to know about the current price of, let's say, one of the burgers from McDonald's, right? So LLM is going to generate all the information passages regarding that query. Let's say 4, 5, 6, whatever numbers you are going to give, and that number of passages will be there along with you. Now you will also get some retrieval from this vector store, right? So now basically you have two types of passages. You have one from retriever, one from LLM. One you have generated by yourself, one you got it from database. So two passages are there, right? Now these two passages you are going to merge, combine the internal and external passages. This you are going to do. Now this you can do multiple times. This, the thing which I said you, number of iterations t. We have a specific prompt for this. Let's go to the prompts. We'll go to the prompts, that is in the appendix section. I'll take you guys there, and we have the prompt here, appendix. Yes, so this is the prompt for passage generation. Generate a document that provides accurate and relevant information to answer the given question. If the information is unclear or uncertain, simply state I don't know to avoid any hallucination, and the question and document, right? So this is the question, and you will be produced a document. This is for which I told you will generate something out of this LLM. Now second thing, prompt for iterative knowledge consolidation. What you are doing here, you guys are going to sort of merge all the things, right? Because there are two knowledge right now. So consolidate information from both your own memorized documents and externally retrieve documents in response to this question. So you have a set of instruction that exclude information relevant to the query. For each new document, create clearly indicate whether the source was from memory, this, that. So a lot of things are there, right? So this you are going to do. And once you have done that, what is the third step? Once you have got the knowledge, also this particular step you can do 2 to 3 times. Let's say you have 10 results from here, 10 results from here, 5 results from here, you have 15. You merge them, you still have, let's say, 9 results. You want to take it down to 5 or 6. You can do that again. You can do that again till it is 5, right? That's completely over you. How many times you want to do that, right? Now the third step is prompt for knowledge consolidation and answer funnelation. Now at the very end you want to do that thing again. Let's say consolidating the information cluster them together, summarize the key details into a single concise document. Obviously because you have a number of information, so you will want to do that, right? Now you are going to again exclude any relevant information to the query. Second thing is propose answers and assign confidence. Let's say you have 5 informations, right? 5 final passages are there with you. For each group of documents you are going to propose a possible answer and assign a confidence score based on the credibility and agreement of the information according to the query. Now at the very end you are going to evaluate all groups, select the most accurate answer and highlight your exact answer within answer. This is a prompt template, it's fine, and then you will get your answer. So basically 3-step thing is there, right? I have tried to explain it, this whole paper, into literally 5 minutes, so I hope you guys get it. I'll explain it once again. You have the whole retriever argumentation generation thing here, cool. Now you will have LLM. Let's say this LLM is specifically for summarization, you can ignore it, but for now let's say, suppose this is the LLM, right? Now this query you're going to pass it to directly LLM and ask it to generate some documents for it. You have generated. Now you have 2 information, one from retriever, one from LLM. Now both the information you are going to consolidate them, cool, you have consolidated them together. Third step is giving that information, consolidated information, and if you want to reconsolidate it, doing that. And finally getting an answer for each type of information. Let's say 5 information were there, 5 information passages were there. You're going to get you're going to get an answer for each from each 5 of them for the query, and you will get a confidence score. And for each, and at the very end you're going to decide the best answer and the confidence score. Cool. So this was it in a nutshell what these guys are trying to do. Now the problem foundation, they're saying that our objective is to mitigate the effects of imperfect retrieval augmentation, resolve knowledge conflicts between LLM's internal knowledge and external sources, which they are doing very brilliantly. And now they have also done it. Now I'll try to show you, but before that, I want you guys to go and read this. This is especially valuable when the majority of retrieved passages might be irrelevant or misleading. So I am currently working on something, performing performing an experiment of how things are going to change even when I'm trying to ask LLM that does the answer exist in the knowledge or not that I'm providing to you, and will re-ranking also help there? Because believe me guys, I have been working with these APIs and models for a while now, and we are even close to AGI. Model can even respond differently, completely differently between true and false if you provide one or two words more that are completely not related to the whole passage, right? So yeah, now they are saying that they are generating the passage based on the given question queue. Following this paper I would definitely recommend you guys to read, because this paper primarily focused on generating diverse internal passage, right? So they are saying that this constitutional AI, we provide constitutional principles indicating the desired properties of internal passages. They are saying guys can go and read this particular appendix, that same prompt that we were saying. So this they are doing, and what they are saying, moreover, this knowledge consolidation process can run iteratively for 3 times to improve the context to be more and more useful. So users can assign a larger number of iterations when context is lengthy. So yeah, that's what we were talking about. So they have done this experiment. This first one is with Claude 3.5 Sonnet. Now guys, one thing I want to tell you guys, this whole process, that this prompt and everything that you are doing, you will see these all things are complex task for a LLM. Not every LLM is capable of doing this. Small language or mid-sized models, not at all possible. Only proper models which are at least above 70 billion, these are the models which you can expect to provide you good results here. Because what I personally feel is this is very subjective, and small models can be fine-tuned for this, definitely that's one case, but the bigger the model, the better will be the results, because that's the reason they have also benchmarked it using Claude 3.5 Sonnet and Gemini Pro. So I'll show you the results. This is Claude 3.5 Sonnet using without any RAG on the same benchmark, 47.12. With RAG they have got 44.41. So you see, hallucination can lead to this. Now there are other currently methods that are used for RAG, so they are improving the accuracy. But using Astute RAG, where they are doing one iteration of knowledge consolidation, 52.20. For 3, they are getting 53.56. Let's take the best case scenario, 53.56. Guys, this is far better than this. This is around 6.5% jump without no RAG. So, and with simple RAG, it's around, let's almost 9.1% jump, something around that, right? And similarly for other benchmarks, you can see. So they are saying we have main results on Claude under 0 shot setting, and we have set the temperature is equals to 0 from what I remember. So you can also see the number of API calls. Obviously in t is equals to 3 we are getting 4 calls because we are doing knowledge consolidation multiple times. Yeah. Now here t is equals to 3 is 4 because instead we are not only doing knowledge consolidation in the final task, but also previously before that 2 times, right? So yeah. Now here is t is equals to 2 because we are going to do 3 times. 2 times we are simply going to do knowledge consolidation, and the third time we are going to get the answer, right? So yeah, when I say about API calls is equals to 2 here, what I am specifically talking about, the first one is generating the number of passages. Number 2 is finally having that bigger prompt. The third one where we are doing knowledge consolidation and getting the results. If API calls is equals to 3 here, means in between those two processes we are again doing one knowledge consolidation. If it is 4 here, we are going to do it 2 times, and the third time we are going to get the answer along with knowledge consolidation, right? So you will see the results somehow and other are better than the usual cases. Similarly, they have done it for Gemini 1.5 Pro, and you can see results look good when you are doing this Astute RAG you are applying. Now the results are definitely good, but from 44.75 to 51, that is a 7% boost. So decent, I would say decent. And the main results and everything, the processes that they are doing, so you guys can go and read the paper in detail. You can see by performance by retriever here, Astute RAG is best here. I won't say it's very different than the other process, but yeah, it has some advantage. Similarly, performance by knowledge conflicts. You can see here Astute RAG is not the best when it comes to both correct, but yeah, it's performing really good. The worst case performance on RGB. So here you can see Astute RAG is still, the accuracy looks really good. Now the related work and everything is a must read for you guys if you guys don't know much about RAG. But my point here is, for a small startup or let's say a company, the number of API calls that we are making here uh, is an issue. The thing which could have been done in one call now takes, for the best case scenario, 4 calls, right? Now, obviously the API calls, it doesn't matter the number of tokens generation, that number of tokens that we are giving as input matters a lot. So as these models are not cheap, not at all cheap, especially Claude 3.5 Sonnet and Gemini 1.5 Pro, they're not at all cheap. Far costlier when you compare it with let's say GPT-4o Mini or GPT-4o. But the point is, obviously you need the best models here, and currently I think Claude 3.5 Sonnet is really one of the best models in the market. And the cost, if it's not the factor for you guys, if anyone of you who is going to implement this, then definitely this is a win-win situation for you. But anyone who has cost in his or her mind, this can be a tricky situation for him, because if you see, the number of calls are almost doubling here, and the number of tokens that you are going to send and get the output for are going to be huge. Previously, let's say you are using a simple RAG, you are just sending a query, uh, documents along with that, and expecting an output. But in this Astute RAG, you are going to generate a whole passage, then you are going to consolidate, then you are going to produce some answer, you are going to send a lot of tokens, you are going to receive a lot of tokens. So this is going to be a lot costlier than a simple RAG, I would say. But yeah, startups who don't care about money that much, a win situation for them. So I'll try to implement this with a small number of samples, just for my internal use case of organization, and see if this works for me. So do let me know what you guys think about this particular process, Astute RAG, and what are your opinions about it. So I will link down the paper as usual in the description, and you guys can go and read it. So yeah, thank you for watching the video, guys. Thank you and have a nice day.